Hi, today I'm going to go over the fundamentals of linear probabilistic modeling and some of the things that we can do with this kind of modeling. Linear regressions are defined mathematically with linear predictor functions, which are of the form y equals beta naught plus beta sub 1 times x sub 1 plus epsilon. Epsilon represents our random deviation or error for our regression. And we can see this on the graph as the distance from each data point to the actual regression line. And there are some other key mathematical components that we want to get from our regression. And those are the correlation coefficient, which is the literal correlation between our x and y variables, and the determination coefficient, which is the percent of variation in our regression. The overall goal of these regressions is to see how well or how poorly our regression line fits the data. And if it's a relatively good fit, then we can start to make predictions and inference about hypothetical situations and test those. An example might be a student's grades, what his future grades might be based on his performance in the past. As you can see here, I have an example linear regression, age versus weight, age being our dependent variable y, and weight being our independent variable x. You can see that charted out there, and the line tries to fit the data as closely as possible, even hitting one point here. However, there can be drawbacks to using linear models for predictive analysis, and that's going to come down to the characteristics of the data and the relationships between the variables and the types of variables. For instance, we may not want any values that go below 0. Well, you can't necessarily stop a linear model from doing that. It's just that's how linears work. They're everywhere. They're anywhere and everywhere. So in that case, we might want to use a logistic model, which is bounded by 0 and 1. Linear probabilistic modeling is popular in machine learning for certain tasks like classification or image or sound recognition. And this is because linear models are simple to understand, they're efficient, and they're easy to iteratively improve. One such example might be recognizing handwritten text. Essentially, what the computer would be doing would be iteratively reducing that epsilon, reducing the error in its linear regression model of the data being a training set of handwritten letters that it's been exposed to. And once it's reduced that error, it will be able to confidently predict what each handwritten symbol actually is.